All right, so today we are going to talk about MicroBits. So Rebecca and I highly recommend that you check out MakeCode.microbit.org. So the link up at the top of our URL. It will have a ton of different tutorials and it launches straight into the coding website. So the first things first, before your students even touch a microbit, is to go to new project. We're going to be doing our nameplates. So I'm going to write my name. I named my file quickly there. And we're in the actual coding website. So right here, what you'll be able to find is on the right-hand side that's already loaded, we've got our start, on start, and forever. This is where we're going to build our code. In the middle, we have all our different types of activities and different functionalities and stuff that our microbits can do with the proper code. So you can see here there's so many options. And all the way to the left is our preview of our actual code. And this is an important part to remember to use because using this digital version of the microbit will help us kind of problem solve our issues before we actually physically touch an actual microbit. So on start, what it means is that once it's plugged into power, it automatically goes and that's it, one and done. Forever is continuous, it will always loop. So I'm going to get rid of my code. So if you want to get rid of your code, you click on a code and it's outlined in yellow and you drag it into the center here, you drop it and it gets thrown out. So because we're doing our nameplate, I'm going to do what Rebecca did. I'm clicking on basic and I'm going to click on show LED. And instead of me starting to type right away, I'm just going to load up 6 keys because that's how many letters are in my name. The other thing to consider is that these are like puzzle pieces. So in order for them to actually work, they need to be attached to one another to the beginning of a code line. And you can see here that I have one that is gray. It doesn't fit in. It's not plugged into the code. So I'm going to drag it and drop it here. So I'm just double checking and I need one more, I believe. There you go. In the bottom right corner, you have your zoom in, zoom out buttons and your undo and redo buttons as well. So a quick trick with this when you're making the code. So each of these boxes represents one of the LED lights found on our microbits, the 5x5 grid. And so essentially we can make like pixel art with this, very basic pixel art. So I'm just going to write my name in all capitals. And if instead of clicking each one individually, what I'm doing is I'm clicking on the first one and then I'm just dragging my finger across to highlight all those boxes. So when they're white, that means that the light will be turning on. When they're dark blue, nothing's going to be turned on. If you have students who have fine motor skill issues, I would recommend potentially using a mouse for this. As they will become frustrated with this process. You can do one by one. Obviously, it will take a lot longer for your students to complete their work if they click one light at a time. It depends on your project. It depends on your student abilities. So once I'm done my code, I'm going to go to the left-hand side of the screen and I'm going to look right here. And it automatically started playing my name. So I can see here ALICIA. That's my name, and it's constantly in a loop. Happy with my code. There's no problems, no bugs to fix. So what I'm going to do is I'm going to click on download, and I'm going to get a pop-up that comes up on my Chromebook where I can save my microbit. So there's 2 ways. You can have the students save directly onto the hard drive of the Chromebook, or alternatively, what I would recommend is actually saving it directly into Google Drive. So how you do this is on the left-hand side, you'll have the different files and you just click on Google Drive and you go to My Drive. And then instead of them just dropping their code in their Google Drive without any organizational system whatsoever, what I would recommend is that they always put their code, their microbit code, in a microbit folder. So the way to do this to get them to create a folder is by clicking on the 3 dots on the top right corner on More and create a new folder. Now, I already have a folder for microbits. Once the students have that, they'll just double click on their microbits folder and just hit save. So this is fantastic because if you are working on a big project, or the students need more time to finish the project, and you only had a period with the microbits or the computers, you can definitely save it and then reload it. So I'll show you in a moment how to reload it. So it's done. Amazing. So the next thing we're going to do is upload it to our microbits. So when you get your microbit, you're going to pull it out. And this one might make some noise, so my apologies. And we're going to plug everything in. Someone's had music on it. And so what we're going to do is we're going to get this pop-up right here, removable device detected. I'm going to open it. And I can see that I have a peripheral right here where it says microbits. So in order for me to drop and have my microbits actually code my name instead of this song and whatever is playing on the LED lights, I'm going to go back to my Google Drive. I'm going to find my microbits folder. I'm going to double click on it. And then I'm going to find my code and then scroll all the way back down to my microbits. So I'm going to click on this. And I'm going to drag it until I get to the microbits peripheral. The music stopped. And you can see here that there's this communication on the computer saying that it's copying to the microbit. So in a few minutes, it'll be uploaded. Hopefully. Nope. Something happened. Sometimes they are a little finicky and they will unplug themselves without warning. Which is no big deal. You just plug it back in, especially if the code's not loaded. So you know the code's loaded when there is a flashing yellow light on the back of the microbit. And at the front, you'll be able to see your code being played out. Now, let's say, so I'm happy with that. And what I can do now is I can unplug it carefully from the computer and then use the battery pack and walk around with my microbit with my name badge. So let's say you're working on a longer project where it's multi-period and you want to use the code that you started in your last class. So the way that you do this is there's an import button when you're on the main screen. When you're on the main screen, for the time being before you log out, you will see all your projects at the top. But once you log out or you're off this website for an extended period of time, it'll be gone. There's no saving to this website. There's no account making, nothing. So this is a pretty good website that's secure and safe for our students to use. So we're going to click on import. And so there's different ways that we can import. GitHub, no clue what that is. We're going to ignore that. We didn't get a URL, so we're going to click on import file. And this is where I can find my files. So this is where the organizational piece is really important on our Google Drive. So students click on Google Drive, they go to My Drive, they find their microbits folder, and then they find their code. And I'm opening that, and it says go ahead. So I'm going to open that up, and here's my code. So let's say I wanted to add some other things, like right here I have icons. So I want to have a heart icon. Let me zoom in a little bit for you folks here so you can see it better. So I have a heart icon, but I can click on that and I get a bunch of different icons as well that I can use that are pre-made for me. So I'm going to use a smiley face. And I can see on the left-hand side that this is updating. And now it starts my name off with a smiley face, and then it goes into spelling it. Obviously, there's a whole bunch of different things you can do here. And there's a lot of flexibility. But this is a way that you can ensure that your students are able to continue their projects if you didn't have enough time to complete them. And then just like before, if they didn't finish their code again, or if they have finished it, they need to continue saving it. They can delete the old code now if they want to, or they can keep the old code, but make sure that they put version 2, version 3, or just create a naming system that they understand that what code is what. And it's really important to encourage our students to create names for their projects so that way they understand what the code is without having to waste time in opening it. So something else I wanted to show you quickly was for our students who are already deep into code, have explored code on their own time or with another teacher in the past, is exploring the other languages that MakeCode offers. So the first one is JavaScript here. So it's just switching over. And you can see that the numbers represent the lines of code here. And you can see that this functionality, basic forever, it will tell you some information about what it is. But for the most part, this is more advanced. But you can see here that with the hashtag marks or the numbers, pound sign, number mark, symbols, whatever you want to call them, they are actually spelling out my name. And it takes a little bit more time because the students have to be more proficient at this and make sure that their code starts and ends. And this is one of the end symbols right there. And so it does take some higher level for students to do this. Same with Python. And you can see here how much different it looks just by a little bit. But the code is a little bit different. And yeah, to be honest, I don't code like this. My knowledge is mostly block coding. So if you have those higher level students who code often, they will understand this a lot better than you or I. So I think that is it. Something I do recommend that you explore are the different activities here. They're really fantastic. So I'm going to go to rock, paper, scissors quickly. And here you can see that you can have the kids start with block, start with Python, or start with JavaScript. And again, this is a great differentiation for your higher level students who code already. And so I'm going to go to block code. And I'm going to start the tutorial. These tutorials are fantastic. They're super easy to follow through. And it explains like this uses the accelerometer that's already built in. So that way it knows it's being shaken. So it actually goes through step by step. So it immediately shows me that I actually don't need my OnStart and forever code. So I'm going to get rid of that. And I'm going to go to input and click on shake. You may also notice that when you're in the tutorials, it actually limits how many functions you're able to use, and it only gives you those functionalities that you're going to use in this code. So as we go through this, it actually shows me what I need to do, make variable, and I can continue on. If I need to rewatch it, I can see what's going on, make variable, the name, hand, and you can see that's happening right there. So there's a lot of fun stuff that we can do here and continue through this all. There are some tricky parts. So like getting this pick random 1 to 3, you would have to go to math, click on pick, and then you're going to have to strategically put it in that circle. So I'm going to zoom in again so we can see a little bit better. So you can see here, I have a gray code. It's not plugged into anywhere, but you see this little red dot there at the tip. If I start pulling it closer to my actual code, it starts attaching itself to this part right here. And I can put my code right here, perfectly fine. And I can continue going through it. And these tutorials are very easy for our students to understand and to just follow through, and they can save it at the end of their tutorial. So there's a lot of fun things that our students can do. I'm going to exit this, and you can see that it's showing me all the different projects I have open. It's showing me that this is a code I made myself. This is an uploaded code, and this is part of my tutorial because I'm on step 11 out of 12. So we encourage you to check these out. We do have the alligator clips that need to be put into the envelopes or the zippies still, but we do encourage you to check them out and start kind of figuring things out and playing and seeing ways that you can incorporate them into your language program, your math program, science, social studies, art, phys ed, health. There's a lot of different ways that we can use these to help our students become more technical and to develop and build their problem-solving skills, because coding is just solving problems. So if you have any questions, comments, concerns, or if you want to collaborate with Rebecca and I, please reach out to us, either, email, text, if you have our numbers, or in the halls. If you see us, please just stop us and let us know if you're interested in working with us. We will have Code Teach, Code Plan time. And so we were looking for teachers who have, a bigger project other than just some Q&A and just basic activities with this. So please let us know, and that would be great. Thank you so much. Have a great day.